atoms. Now moving on to the third bond is coordinate covalent bond. But before it, I can also tell you about the polar and the non-polar covalent bonds. Polar covalent bond is formed between two similar atoms, that is hydrogen and chlorine. As a result, hydrogen has partial positive charge and chlorine has partial negative charge that are equally distributed. Whereas non-polar covalent bond is the bond formed between two same atoms. Like there is no partial positive or partial negative charges, but the charges are neutral. So now moving on to the third bond is coordinate covalent bond. The coordinate covalent bond is a type of coordinate covalent bond is a type of dipolar bond. Coordinate covalent bond, we can write it here. It's a type of bond which is also called coordinate bond, dative bond, semipolar bond. So in this bond, what happens that electrons are shared in the bond from the same atom. For example, its example is very common, that is ammonium chloride. When the ammonium ion is formed, the fourth hydrogen is attracted by the, here I'll tell you the example, ammonium chloride, I will tell you how it happens. It is chloride ion. As you know, chlorine has 17 electrons. Hydrogen. As a result, what happens?
It has been 7 minutes.
It's a negative charge, and this is coordinate bond. Now I'll tell you how this happens. When the ammonium ion is formed, the fourth hydrogen. This is the fourth hydrogen. The fourth hydrogen is attracted by the dative covalent bond because only the hydrogen nucleus is transferred from chlorine to the nitrogen. The nitrogen electron is left behind. As you can see, the nitrogen electron is left behind. Once the ammonium ion has been formed, it is impossible to tell any difference between the dative bond and the ordinary bond. Although the electrons are shown differently in diagram, there is no difference between them. As you can see, here is the fourth hydrogen bond, which came from the chlorine atom. And this positive charge, the positive charge here told that only hydrogen nucleus has removed from nitrogen, and the negative charge here tells that negatively charged because nitrogen has left behind of this electron. Now the last type of bond is metallic bond. So moving on to the last one is metallic bond. So the chemical bond that characteristic of metals in which mobile electrons are shared among them. So in metallic bond, mobile electrons are involved. So mobile electrons are shared among the atoms in a usually stable and crystalline structure. The structure of metallic bond is quite different from the covalent bond and the ionic bonds. In a metal bond, the valence electrons are delocalized, meaning that an atom's electrons do not stay around the one nucleus. They are just delocalized along the surface. That the positive atomic nuclei are surrounded by sea of delocalized electrons in which they are attracted to the nuclei. I can tell you that these are the positively charged nuclei, and electrons are not stick only to the one nucleus. They are just like this. They are floating around the nucleus and they are delocalized. Here you can see. So this is the metallic bond, which is such a bond that involves the mobile electrons, and the electrons are not stick only to the one nucleus. They are delocalized, moving around the nucleus. So there are also some properties of metallic bond. In the end, I'll tell you about the properties of metallic bond. So there are so many properties here. We can discuss few of them.
11 minutes past.
Number one is formed between atoms of metallic elements. Metallic bond is the properties that is formed between the atoms of metallic elements. Number two is electron cloud around atoms. Number three is a good conductor at any stage that is lustrous and it has very high melting and boiling points. And some examples of metallic bond is sodium, iron, aluminium, gold, and copper.